We've been telling you about the search for a meteorite that landed in the Sierra foothills outside of Sacramento. Several fragments have been found, but scientists are still looking for more. However, time is of the essence. Dr. Dave Morrison from NASA Ames joining me tonight to explain why finding this particular meteorite is so important and why they have to hurry up. Thanks for coming by. I appreciate it.
It's my pleasure.
So are they finding more? They're still out there, I think, right?
Yeah, they've found about 25 so far. And I say they, it's mostly the local residents who go out and search. There are a few scientists, but most of it's been done by amateur sleuths who managed to find these and pick them up.
All right, so you were just showing me they're looking for meteorite. You were going to show me a meteor wrong.
Yeah,
because you have to, when you're out there, how do people know that they've got the right thing?
Well, some of them make mistakes. There was one actually on eBay that they were selling for $700,000 today that wasn't a meteorite at all.
Mm-hmm. So hold up your rock there and then...
Okay, this is the kind of thing that people are finding. Little black rocks about this big.
Mm-hmm.
And this one, I'm afraid, is a piece of asphalt. But it looks a lot like what we're picking up. And these are pieces of a meteorite that was formed 4.5 billion years ago and has been in the outer solar system in deep freeze all that time until it came to Earth a week ago.
So if you could find some pieces of this and you could do some lab work and look for stuff, what could it tell you? Why is it different than any other meteor that you find?
This kind of meteorite is really what chemists call primitive. It's made of carbon compounds, of amino acids, of all the building blocks of life. So we think that the building blocks of life on Earth came, at least in part, from impacts of this kind of material. And we now get a chance to, in effect, look back and see what the chemistry of our planet was 4.5 billion years ago.
And if we don't collect this stuff soon, if you don't find it, you leave it out there, it's not like you've got 10 years to locate the pieces. What happens to what's currently out there?
It's just a very soft rock. The water gets in it, and it kind of, actually, microbes eat it. It's good for them to eat. Within a few weeks, it just goes into the soil.
So if you don't find it, you miss the opportunity.
That's right.
Mm-hmm.
But there were an awful lot of pieces. As far as we can tell, it exploded. It was this big, mm-hmm. and it showered thousands upon thousands, probably 10,000 little pieces like this. And most of them just landed in the forest or the fields. Nobody will ever find them.
And so you're looking for bigger pieces. Why? Why? You mentioned you have a bunch of little ones, or they have a bunch of little ones. Why do they want larger ones?
Partly it's that a bigger piece is not going to be weathered as quickly as a small piece. A small piece left out in the rain once is already starting to go. A big piece will hold itself together. Besides, a big piece is actually very valuable. This stuff is worth between 50 and 100 times as much as an equivalent weight of gold.
Wow. And that's the monetary value. Of course, there's the scientific value as well.
That's right.
So how often do you get one of these particular meteorites? When was the last one? I think somebody told me there was one in '69 in Australia or something.
Yes, and there was one in Canada about 20 years ago. It's not very often.
But they continue to study them, right?
Absolutely. Once you get it in the lab, once you put it in a dry atmosphere and protect it from water and microbes and so on, then it lasts a long time. And the beauty of it is that modern scientists are able to analyze tiny, tiny bits. Just a little flick of material off of here can go into these fancy, huge analysis machines and tell us a great deal of detail about what it's made of.
What do you hope to find from this one? What would be kind of the key essentials if you could get some information out of these meteorites, out of these fragments?
We want to know what these chemical building blocks were in the early Earth. And one of the interesting things is that these have amino acids in, just like you're made of amino
mm-hmm.
acids. But yours are all either right-handed or left-handed. Here it's a mixture. In space, in the natural origin of things, you get as many of one kind of amino acid as the other. Somehow our life uses only one kind.
Is this the kind of thing that if this splashes down on another planet that currently doesn't have life but could host life, is that the kind of thing that would spark life? That kind of...
Probably a necessary but not sufficient condition. You need these kind of chemicals, but you probably need a lot more to have the right circumstances. And frankly, we still don't understand exactly how life came on Earth. And so we have a hard time predicting whether it would be on Mars or Titan or any place else, which is why we want to go look.
Right. So how did you know to look for this one in the first place? It's coming out of the sky. And how do you know that one's important, let's go look for it, as opposed to any of the others that fall out of the sky?
Well, it was big. That was the main thing. It was seen as a daylight fireball going across the sky. It was picked up by radar. It was this explosion, and lots of people knew about it. So, of course, you went out and looked. And the first piece was found within a day, and by a meteorite expert who looked at it and said, whoa, this is an interesting one. And the news just got out like wildfire.
All right, so they got a few more days to hopefully get it before it's too late, but hopefully they'll get some good information.
That's right.
Thanks for coming by. Always good to see you. Very interesting
My pleasure.
stuff. Yeah, let's see what they find in the days to come.
Yes, sir.